Dear students, welcome to the first session of our Chapter 8 Redox Reaction. Before starting this chapter, we have to understand what is meant by these redox reactions. The word says it is coming from red plus ox. That is, a red means reduction and ox means oxidation. So, in a chemical reaction, if both these processes, that is, reduction as well as oxidation takes place simultaneously, we say that type of reaction as redox reaction. That means one of the species is getting oxidized and the other one is getting reduced. Now let's see the different meanings or different definitions of oxidation and reduction. In terms of oxygen, if we explain the oxidation and reduction, that is how we can explain is it is the gain of oxygen which we are saying oxidation. That is, magnesium is oxidized to magnesium oxide. And in what about the reduction? It is the loss of oxygen in a species. So it's the reverse. One is gain, the other one is loss. And here we can see the water is reduced to hydrogen. If we talk about the oxidation and reduction in terms of hydrogen, we can explain that one as oxidation is the loss of hydrogen in a species. H2O is oxidized to O2. And in the terms of reduction, when we explain, it is the gain of hydrogen in a species. That is, oxygen is reduced to hydrogen peroxide. Now let's see the thing which we have to note. While we are defining the term oxidation or reduction, the loss or the gain of oxygen when we are talking, it's not the O2 minus ion or oxide ion. The same way, when we talk about the hydrogen's gain or loss, it is not the H plus ion. That we have to keep in mind while we are gaining the oxygen or losing the oxygen or gain of oxygen or loss of hydrogen is there. Now let's see this example which we have explained through the gain or the loss of oxygen and also the gain or loss of hydrogen. The first one example is the gain of oxygen, that is oxidation. 2 mg plus O2 giving 2 MgO. You can see here the addition of oxygen is there. That means it is the gain of oxygen. So how we can explain that one? Magnesium is oxidized into MgO, right? If we talk about the oxidation in terms of hydrogen, it is loss of hydrogen. So how the equation comes? 2HCl giving H2 plus Cl2. So how we have to explain? HCl is oxidized into Cl2. The reduction when we are saying it is the gain of hydrogen. So Cl2 plus H2 giving 2HCl. Addition of hydrogen is there. So how we will explain it is Cl2 is reduced into HCl. Last one, loss of oxygen is also reduction. So how we explain that one? 2 MgO giving 2 Mg plus O2. That means MgO is reduced into Mg with the loss of oxygen. So with the equations, how we can explain the oxidation and reduction in terms of oxygen and hydrogen, we have seen here. Let's see this general chemical equation, that is magnesium plus lead oxide giving magnesium oxide plus lead. In this reaction, you can see the gain of oxygen is there for the magnesium, that is Mg is changed into MgO. That means the oxidation part has been completed. What about the lead oxide? Lead oxide is converted into lead. That means the loss of oxygen is there. So it is what? The reduction. Now what we can explain through this equation is the magnesium is acting as the reducing agent, which the substance or the species which experiences the oxidation is said to be the reducing agent. Same way, the substance which experiences reduction, it is said to be oxidizing agent. So we are having in this reaction itself the oxidation, reduction, oxidizing agent, reducing agents. So what is oxidizing agent and reducing agent? We have to understand. The species which experiences the oxidation is said to be reducing agent, and the species which experiences a reduction is said to be the oxidizing agent. Now let's see the next definition for the oxidation and reduction in terms of electrons. That is, we are using here a small word, that is oil rig, OILRIG. This represents oxidation is loss and reduction is gain. O stands for oxidation, I is, L for loss. Same way, rig, R represents reduction, I is, and G gain. Oxidation is loss and reduction is gain. So in terms of electron, while we are saying, we have to keep in mind that oxidation is the loss of electron and reduction is the gain of electron. So here when we are explaining, the oxidation is the loss of electron. The example when we see magnesium is oxidized to magnesium oxide, the same equation it is. But when we say in terms of electron, it can be explained like this. That is, magnesium is having what? How many electrons? 12 electrons. When it is getting oxidized to magnesium oxide, what happens? The electrons, that is 2 electrons are lost, right? 2 electrons are lost means it becomes Mg2 plus in MgO. So we are explaining the loss of electron is oxidation. Same way, if we want to explain the reduction, it is the gain of electrons. That is, oxygen is reduced to hydrogen peroxide. We know that oxygen is having how many electrons? 8 electrons. And it changes to 9 electrons per oxygen in O2 2 minus. That means the gain of electron from 8 to 9, it becomes, that is, gain of electron. So it is said to be the reduction. If we say the oxidizing and reducing agents in terms of electron, how we can explain? The oxidizing agent or the oxidant gains the electron and is reduced in a chemical reaction. Same way, the reducing agents are, we can name it as what? Reductant also. Losses the electrons and is oxidized in a chemical reaction. That means the oxidation is the loss of electron. That means it will be acting as the reducing agent. Where the electrons gain is there, that part is reduction. And the species getting reduction or experiences the reduction is acting as the oxidizing agent. You can see here the example, that is Mg plus sulfur giving magnesium sulfide. Magnesium's, you can see here, is getting converted into MgS. The oxidation state or the loss of electron or gain of electron, you can see here. Magnesium, where the 12 electrons were there, it becomes here Mg2 plus. That means 2 electrons has lost. Has lost means this is what the oxidation part. So magnesium will be acting as the reducing agent. Whereas the sulfur, where it was having how many electrons? How many electrons you can see here, whatever the zero, it is elemental oxidation state because the element it is. And it changes to S2 minus. 2 minus represents what? The gain of 2 electrons. Sulfur is having how many electrons? 16 electrons. And here minus 2 means what? It has gained 2 more electrons. So what happens is, this part is the reduction. So if the sulfur has reduced to sulfide ion, the sulfur will be acting as the oxidizing agent. Now let's see the fourth definition of the oxidation and reduction in terms of oxidation state. Oxidation occurs when an atom's oxidation state increases during the reaction, and the reduction is when the atom's oxidation state decreases during the reaction. So in this way also we can explain the oxidation and a reduction. With this example we can understand that thing. That is methane plus oxygen giving carbon dioxide plus water. Here each atom is having an oxidation state. That is, carbon will be acting here as the -4 oxidation state and hydrogen +1. Oxygen is in elemental state, so it is 0. What about the carbon dioxide? Carbon +4 and oxygen will be having -2. In water, one hydrogen will be having in +1 oxidation state, the other oxygen will be -2. Now you can see here the carbon is having a change, -4 to +4. -4 to +4 means there is a increase in oxidation state, right? And what about the H plus? Here H plus is plus 1. Here also H plus. Both the sides when we see it is in same oxidation state, so that we don't have to consider. Then next one, oxygen. Here in the reactant side, the oxygen is in elemental state 0. And on the other hand, product side, it is in minus 2. The same way, the other one also minus 2. So what we can understand, there is a decrease in the oxidation state from 0 to minus 2. So in this way also we can explain the oxidation and reduction. Let's see this general equation. MnO4 minus plus 5 Fe2 plus 8 H plus giving Mn2 plus 5 Fe3 plus 4H2. In this reaction, MnO4 minus, the manganese will be having plus 7 oxidation state, oxygen minus 2. Iron, we can understand with this ionic form, plus 2. H plus, that means plus 1. Mn2 plus 2. Fe3 plus 3. Hydrogen plus 1. Oxygen minus 2. Now let's take the oxidation state of MnBx. How we are getting? Thus, MnO4 minus, how we have to find out the oxidation state of manganate ion? That is, you have to put for MnX plus, how many oxygen is there? 4. So 4 into, what is the oxidation state of one oxygen? That is minus 2 into 4 into minus 2 is equal to, you have seen here minus charge is there on the ion. That is minus 1 we have to write. Solving this, we are getting X is equal to plus 7. That's why we have written here plus 7. So any compound, you can find out the elements or the atoms oxidation state through this way. Now we can understand one more thing. Manganese is getting reduced from oxidation state of plus 7 to plus 2, while iron is oxidized from oxidation state of plus 2 to plus 3 in this reaction. Here plus 7 to plus 3, plus 2 to, plus 7 to plus 2 for the manganese, and for iron it is plus 2 to plus 3. So what we can understand, plus 7 to plus 2, it is getting reduced, or what we can say, it is the decrease in oxidation state. And what about the other one? It is the increase in oxidation state. So just now we have explained the increase in oxidation state is what? Oxidation. And the decrease in oxidation state is what? The reduction. So this way also we can explain the oxidation and reduction part. Now let's see what is this oxidation number. Oxidation number is said to be oxidation state also, and it is the number of, or the total number of electrons that an atom either gains or loses in order to form a chemical bond with the other atom. Now if we are taking an example of carbon dioxide, the oxidation state of carbon is plus 4. How? Because we know that carbon's outermost shell 4 electrons are there, so it needs either the plus loss or the gain of 4 electrons. So we are taking here plus 4, the loss of 4 electrons, because the other one should be negative. Oxygen is of course the negative, that is O is having what? The deficiency of 2 electron to become stable. So its oxidation state, that is the carbon's oxidation state, will be 4, as well as the oxidation number. Same way, if we take the oxidation state of oxidation state of oxygen as well as the oxidation number of oxygen is minus 2. One of the oxygen, if we take, it is minus 2. And if here 2 oxygen is there, that means it becomes minus 4. So it balances or neutralizes. One is plus 4 and the other one is minus 4. So it's a neutral molecule. This implies that the oxidation number as well as the oxidation state of an element in a compound, or it denotes the oxidation state of an element in a compound. Now let's see some of the rules which we have to keep in mind while we are writing the oxidation number. For the free elements like molecular elements, hydrogen, oxygen, ozone, nitrogen, fluorine, chlorine, bromine, iodine, P4, S8, they all have the oxidation number of 0, or what the oxidation number as well as oxidation state is 0 for these elemental forms. Now other case is what? Fluorine. The fluorine will be having every time -1 oxidation state. Fluorine in because F2 it makes what if it is coming with another element, then what happens, the oxygen fluoride or like that compounds, if it is there, oxygen will be exhibiting what? -1 oxidation state. Then the hydrogen exhibits every time the +1 oxidation state. But in the case of hydrides, it will be exhibiting -1 oxidation state. So we can give here the examples like water, ammonia, hydrogen sulfide, HCl, HNO3, H2SO4. These all cases, the hydrogen is having a +1 oxidation state, while the hydride compounds like alkali metal is combining with hydrogen will get hydrides. Lithium hydride, sodium hydride, magnesium hydride, these all cases what happens, lithium plus charge is there, so hydrogen will be minus. That means hydrogen is in -1 oxidation state in these type of compounds. Now let's see the oxidation number of nitrogen in ammonia. How to find out? If we want the nitrogen's oxidation number, we have to put X there, plus how many hydrogens are there? 3, into what is the charge on hydrogen, that is +1 oxidation state. So 3 into +1 is equal to, after is equal to, what we have to write is, if it is having any charge we have to represent that one, otherwise it is 0 because it is neutral. Solving this one we'll get what? X is equal to -3. This means the nitrogen in ammonia molecule exhibits -3 oxidation number. The next one is to calculate the oxidation number of sulfur in sulfuric acid. Here we know that 3 atoms are there. And the easiest one is what? Hydrogen and oxygen we know. Hydrogen exhibits +1 oxidation number, oxygen -2. So we can put here X value for sulfur, or here in this it is represented as this S itself. 2 into hydrogens +1. So it becomes 2. Sulfur S. Then 4 into oxygen is -2. So 4 into -2 becomes -8 is equal to, there's no charge, so it is equal to 0. Solving this one, we will get S is equal to 6. That means sulfur is in +6 oxidation state in sulfuric acid. Next one, if we want to explain the oxidation state of hydrogen in water, the easiest way is we have to put the hydrogen's X value. So how many hydrogen? 2. So you have to use 2x plus 1 into how many, what is the charge on oxygen? That is -2. So it becomes 2x plus -2 is equal to 0. X is equal to +1. So in water molecule, hydrogen exhibits +1 oxidation state. Same way, if it is asked for find out the oxidation state of nitrogen in ammonium ion, we have to put X plus 4 into my +1 is equal to what? The charge is here, plus. That means +1. Solving this one, we are getting -3 for nitrogen in ammonium ion. If we want to find out the oxidation state of sulfur in S2O3 2-, you have to put 2x. S2 is here. So 2x plus 3 into -2 is equal to, the charge is -2. So -2. Solving this one, we are getting +2. So sulfur is in +2 oxidation state. The last one we will see, dichromate ion, the chromium's oxidation state. 2x plus 7 into -2 is equal to -2. We are getting X value as +6. That means chromium is in +6 oxidation state in this dichromate ion. Like this, we can find out the oxidation states for any of the atom in any compound using this method. Thank you. We'll continue in the next session.